I told you. I said it was going. We were in a thunderstorm warning. I told you it was going to rain. It rained. Knocked the internet out for a few seconds. I'm glad that it's back up and running, but that is... Oh yeah, that is very annoying. That is very, very annoying. That is very, very annoying. I need to work on my rage picture. I have a shock picture, then I have a, oh, super shocked. I even have a, hey, how's it going? Hey, how's it going? I need to expand out on the rage, because, putting my arm up, putting my leg up isn't exactly rage enough. I need my character to be, this looks angrier than that. Well, I'll work on it later. Anyway. Yeah, it rained. We knocked out the internet for a minute. We're back up and running, so we will continue going as fast as possible. And I just had an idea. I need all of that information stored together. So if you look, I have one thing that I was thinking about is open cv2. So cv2.imwrite. If we go into here, into this method, let's not go with you. So if you go into here, there is a... Okay, you know what? Maybe here we go. We'll go to the actual source. This is what I'm talking about. We need to know the fundamentals. Let's see here. So that's I am read. Where's write? Where's write? Right. 19. Okay. Oh, come on. There is a bit of code in here that I wanted to show. I am right parameters. Oh. Is this like a long... Is this going to be like a long forgotten code function? Oh, all right, screw you guys. Okay, let's actually go to here and go to I am right. I am right. If we go in here, we have a thing called parameters right here. Params. It's a typing sequence int. Or I wonder if there's a typing override going on. So what we need to do is, if this here, this parameter, if this means I can save metadata to the image, then what I'm going to do for the positioning information is actually save it within the image. I kind of remembered this because I have there's another program that I use because I like to create. So I found a program that allows me to do all sorts of different creations. And what it does is it saves all of the information within the image. So the metadata within the image is what it's used to recreate the... It's what's used to recreate the models in this 3D environment. This way it allows you to have effectively these really tiny files that you can look at. And if I can do the same thing here when I do I am right using the parameter function, then this means that I don't have to... I can store the positional data there. I don't have to try and put it in a config, or... Because I was originally thinking, oh, I know, I'm going to rename the file to have at the very end and the positioning information, but if I can save it in there. However, we need to... Let's see here. We'll call it params. I need to find an example. Scalar, will you be nice to us and have no, you won't be nice to us. None of you are nice. You're all just evil people. All just evil, evil people. And how? Okay, maybe we go to Google. Maybe Google will be nice to us. cv2.iamwrite params. Can't find params. Here we go. Couldn't find CV. Oh, I get it. The parameter. All right, so the parameter is this here. That explains why it's an integer. Because the way that CV2 it uses, or how it's housing its parameters, like what kind of compression it is, what kind of bit depth it is, if it's RGBA or if it's grayscale, it's all of these right here that get converted into an integer, and then that integer is passed in. All right, so yeah, that means we can't use. Yeah, we can't use parameters as a way to save the info. But that means, how do we save metadata? How to store metadata into a PNG with CV2? Hey, 2 years ago. Stack Overflow. That sounds great. Oh no. You can use this. Pill. But no, I'm not certain I understand what you're trying to do, but I think you're trying to process an image with OpenCV and then reinsert the EXIF data you lost when CV opened it. So hopefully you can do that, what you're already doing, but also the image with Pillow, and extract the EXIF data and then write it to the image processed by OpenCV. So here's our image open. Read your image with EXIF data using Pillow. Then we can, then you'll get a dictionary like this. Open CV image as PIL. Make memory buffer for JPEG encoded image. All right, convert OpenCV image to a PIL image. Okay, and then encode newly created image into this with an EXIF. Wait, does that mean that OpenCV can't have EXIF data? But that kind of makes it a bit difficult, because I'm trying to separate OpenCV and Pillow together. There has to be a way to save metadata with OpenCV, right? There has to be able to, let's see here. I have a strong suspicion that that might not be the case. Yes, I know. Looking through, there's CV2. There's our gammas. There's our warping. Near our neighbor. Is this not a thing? I am right to OpenCV image code. Okay then, so here's a question. How is metadata stored in an image? Metadata is stored directly in an image as a standardized blocks of text that encode embedded alongside the image data pixels. Well, yeah, I know. These tags are usually written in industry standard formats like EXIF, camera settings, IPTC, copyright, or XMP, custom data. Well, we're going to be using XMP. Let's see here. Eli 5, how does metadata work? Yeah, how does metadata work? Specifically, metadata is a non-photo image. Metadata seems... Thank you, big relief. Some file formats, like photos, have a support of metadata inside, such as JPEG supports metadata. Does PNG support it? I think it does. I remember PNGs holding a variety of different data. A tool like Image Magic can remove all metadata from an image of any type. Yep, and here's an example that they use a PNG. So yeah, PNG stores metadata. Okay then, so Python, OpenCV, save XMP data to image. It does not natively support writing metadata. Okay then. The PyExiv2 library is highly reliable for modifying image metadata directly in Python without losing your structural image modifications. I've never heard of this environment. Man, dependency hell. Python, it really is dependency hell. So let's see here. With our image opened right here, we can then, so looks like we're going to have to do a post injection. Okay. Okay, all right. So post injection with PyExiv2. So let's check out this PyExiv2. Here we go. Hey, Leo Hasai. How's it going? Is a Python library for reading and writing image metadata. Exiv, it can write XMP. All right, that's good. Good to know, good to know. That way we don't have to mess with camera settings. Granted, we're not using it. Granted, I could technically put everything in EXIF if I wanted. I think there would be a lot of complaints though, but all right, Python, we need Python greater than 3.8. All right. Similar projects. It's a C++ library. C2, C3. This was last updated a year ago, mostly written in Python. Why don't we go in here and have a look into the code. There's our libraries, our tests. There's the core and the convert. So Exiv API, okay. Let's dive into the core. Let's see here. So they have class image. Open an image based on the file path. Read and write the metadata of the image. Please call the public methods of this class. I see, all right. Oh, here we go. Here's the modifies. Modify Exiv, modify IPC, modify XMP. And is using a function called dumps. So we're importing in dumps, aren't we? Yeah, from the .convert code. So this one. There's parse, dumps right here. So for dumps, we get the tag and the value. All right. Okay. All right. So that's how we're inputting in the data. Now my question is, there's our encoding, XF converts, the different file, XF to XMP. No, we're just going to go directly to saving XMP. So my question is, how is this being loaded? Where's the read function? Here we go. Exiv image, read Exiv detail. So it's the Exiv API image. Is there an XMP to API? I don't really see it, but let's go ahead and hop over to this one. Remember, it was in library. then this is all in C right here. Look at this. This is all C right here. Hey, we found the C code. The namespace is pybind11. There's our log handler. Here's our log level. There's the read. Oh, here. Pyline. The result should be pylist, not a pyjix, because a tag can be repeated. Ah, yeah, that is true. Class buffer. We're making a const, which is a pointer to a data. Then long size. Here's our buffer. Let's see here. Buffer. There's destroy, which is to delete data. There's our dumps. Bit. Here we go. Okay, so this is actual bit extract. All right, then. That's what I was looking for. So there isn't just some kind of special call. You actually have to dig into it and start reading the bits. Yeah, here's another one for reading the EXIF. You go in and then you start pulling out the bit. All right, all right. I kind of thought that's what they were doing. They were reading the additional bits at the end of an image. All right, I guess we'll install this. PyExiv2. This one. Can't read an image larger than 2 gigabytes or modify an image larger than 1 gigabyte. Not thread safe because Pixiv uses some global variables in C++. All right. Oh. Okay, maybe we shouldn't save the parameter information in with the image then. But it would make so much sense to save the save that. I'm thinking, because I need to figure this out. Okay. All right. So we know for a fact that we cannot save metadata. But we also know that we want to, when we crop our image, we also want to store that information. And the key point is that the way the data is going to be stored is we're going to have, let's see. Well, let's go, since we are just figuring things out, why don't we just go ahead and start, yeah, perfect. Here we go. This will be, this right here will, so let's go ahead and start messing with it here. So mouth is, this right here is what we're going to be changing. So the idea is we're going to have a folder here called ddmouth. This is going to, because we're going to be renaming this, this is going to be open. We'll call this 03 open, or we'll call it wide. And then this right here happens to be O1 closed. Now we need the mouth here. Interesting. I wonder why VRIs is in all of these. I don't recall VRIs changing. Oh well, doesn't matter. Doesn't matter. Okay, then and then this is going to be O2 open. So that's the body type. Now the next thing here, I'm just going to go ahead and delete all that. We're going to call this the core. In fact, all of this can be moved to here. That way, there we go. So we have our sets. We have our... it should probably still be there probably should still be a frame in here. Most of it's, however, going to be all contained. So yeah, here's our 3 frames for our set. Here's our, technically our 1 frame, because the body is not changing, which means we don't need to... I think that might be a important distinction. Let's go ahead and add that into our code. So we have our layer modes. We have static, dynamic, variant. In this case, we can also add in keyframe. Keyframe, and in this case, this is the layer that all other layers... Instead of calling it keyframe, we'll call it key layer. Layer that all other layers attach to. Can only be 1. And then by that logic, when we're over here, the body, which I marked down as variant, is the key layer. Let's see here. So the arms are variant. The oh, that means this would have... Oh yeah. Oh, okay. All right. So maybe that might not work. All right, let's just continue organizing and figuring things out. So the next on the list is going to be the tail. So this is ZZ tail. Oh, wrong button. And actually, in this case, I can just grab that. Come on, let me out. I can just grab that from here. Here it is, the tail. Hoodie, angry, idle, or... This was the one that we were messing with, wasn't it? Angry, idle, player 1. Yeah, here it is, tail. There we go. So there's the 12 frames right there. All right, all right. So this is variant, and the arms is also variant. I don't see arms here right now, so let's just go ahead and add it in. There we go. Okay. All right, here we go. So now we know that the arms is variant, the body is variant, the mouth is dynamic, and the tail should be dynamic as well, but think about it. Think about it. The idea is that the mouth is controlled by the audio. So the mouth is controlled by audio. This is why it's dynamic. It's because it's being controlled. But the tail was originally going to be static because this is going to be by a random number generator. So RNG is going to control the tail. Hence why it was going to be like that. So, technically, I think I'm just going to focus on speeding things up right now while I think about this complicated mess. Let's see here. The main point is that we need to... Oh. I think maybe I should just keep the tail as a static component. Generate a bunch of different frames. And then the dynamic part, you know, maybe I'm overcomplicating it the way I think. Because the idea was that the mouth will change all the time. But the other things like the tail and such will... yeah, I think I have multiple ideas currently conflicting with each other. Which is what's causing me to get lost in the details. Alright, I'm just going to program. That's the best course of action. Let's just start programming. Let's go ahead and rewrite this layer to frame. And so that it's not a garbled mess. And as we do this, it should potentially help fix things up. So the first thing here is running this code here. When we find the variant type, which happens to be the arms and the arms and the body, instead of taking the image and then renaming it and moving it over, what it instead is going to do, it's going to copy the folder right here, and then proceed to process them. So if you can see here, we get our... So here's our location path. We make the dir. We then grab the variants that we're looking for. From here, we'll then generate the body list. And then we'll run through. And the way that the reason why it's set up like this is because if we hop over to here, V2, we go in, you can see here are the different variants, and inside are all of the different body types. So here you can see there's casual, down, game, and up, which is where the different position of the arms. And then here you can see the same thing here in arms. So because of that, when we hop in, we need to go through and find out which one of these we're processing. Hence why we have the variants. This is just to locate that folder, the path of that folder. And then once we have that, we then simply do a copy and paste over. Now, because we're trying to, we want to change this now. So here we have the different items. What we want to do is we're going to im.readImage. So im. Oh, where are you? There's open. Is it open image? No. Load image. There we go. In this case, it's going to be item. This will be image. So there's our image. We're then going to call, this will now be cropped image. im.autocrop. And if I recall, this is going to output the image, and then this will be the position. All right, come on, import MP. Thank you. A variable annotation cannot be combined with a tuple. Oh. Oh, I see. Yeah, that. That's, okay. We're going to separate these two out, like so. Crop image is going to be an NDR, right? Hey! Hi, Moochie. How's it going? Fake dev? No. Not a fake dev. I might not be the best of the best. I might not be the Primogens or the KC9stats or the TJs, but definitely building stuff. A developer is just someone who programs. Oh. How's it going? This happens to be a tuple full of 4 integers. All right. Oh, and of course I need to bring this in. Now then, from here, now with our crop image, we're going to write it, im.write. So here it's going to be crop image. Let's see here. So crop image, and then this is going to be the new location. So let's see here. This is our variant paths. Okay, you use Ubuntu with an IDE. I personally use Arch Linux with Hyperland and Vim. You're working on your own compiler from scratch. Oh, that sounds fun. Yeah, a lot of people, I see a lot of people talking about how great Arch Linux is. It's a very command line focused. I do have Vim on here. I'm using that for programming C, but since I'm using Python, I kind of like the ability to, go, oh, where does this go? And then I can, load it up and start looking for it. I know that NeoVim has this tree structure. I just keep forgetting what the keyboard input is. But yeah, you can use that as well in NeoVim. I need to remember. Okay, so from here, and naturally I lost my train of thought, so let me go back over here real quick. There's our animation emotions, enum, art generator, importers. Here it is, later frame. Down we go. I was adding you, or here it is, right here. So, item. So the path, local paths. That's what it was. All right, I need that. That line of code. I should probably rename that. That way it won't be so confusing. So let's go ahead and call this the new path, or the... We'll call this the safe path. Oh. Just Vim. Oh, you're just using Vim. Wow. I've had too much help. I prefer without syntax highlighting. Oh, I see. I see. Oh, you're going old school where none of the help is there. No need for a debugger. At some point you will. Once the human brain can only hold a certain amount of information. At a certain point, your brain starts mushing information together. I'm a neurobiologist, so I know all about the brain. I can go into detail if you want now. Let's see here. All right, so now that we're here, this is going to crop our image and save. So we need to save the position information. That's what I guess why don't we go ahead and just install it? I know that... Oh, thanks for the follow. Yeah, thanks for the follow. I guess we'll go ahead and install this. PyExiv2. I know that it says that it's not... it's not memory safe, given that it's using some global variables in C. You stop doing that, you. Yeah, right here. Is not thread safe because it's using global variables, but given that what we're working on here, this is just a conversion of images from one file to another, that I think it should be fine. Actually, OpenCV can't read this information. I just remember that. Okay, screw it. We're going to... I can't think... I've been thinking about this for the last 30 minutes. I can't figure... Let's just go ahead and get this information. All right. So let's see here. We already ran this, right? Image manipulator. Here's A. Folders. I do not see our image example. So we'll just go ahead and rerun this. All right. All right, we need to get to F, so... Okay, we need to run some code. Let's see here. I think... It should be... Where is our test code? Come on, test code, where are you? I believe it's this one. Yeah, here it is, this one. All right, let's go ahead and run that real quick. Animation component. Oh. Let's see here. Key does not have... I think I might know what the problem is. For the users. I see, I see. So what are you working on? I know you mentioned that you are working on a compiler, but what exactly are you programming? Building an emulator? Building an app for like animation tools? Oh, I know. Much I/O. You're building I/Os, aren't you? Much I old V. Hey, I can read it. Okay. All right, so we're throwing an error here. Probably because I've been borking the day, messing with all of this stuff. Because technically this should be fine. I didn't change anything in the importer once I started once we started doing the modifications. All right then. String has no attribute called name. Importers, locate layer. Oh. I know what's going on. It's because, as I said, I've been messing with the data structure here. I've been going in here and messing with all of this because I'm trying to figure things out. All right. Maybe if we pick a different, something that I haven't been messing with lab code. Let's go ahead and let's see here. Let's change this to lab coat. I know I haven't been messing with lab coat at all, so. And I'm gonna have to fix this problem. I'm gonna have to fix this. Oh, actually, this is an even bigger problem than I thought. Oh no. Oh no. Oh, we're gonna have to start digging in. As I said, I compiled the program and I see. I see. Okay. Okay, so let's see. PyCharm importers. We're throwing this error. I'm gonna let's see here. Boop. So yeah, it's definitely in here. How did I mess this up again? How long have you been a developer? I've been programming for a while. I mean, I've been using Python for many, many years. For writing production line code, it's been much shorter than that, but because, research, there's you need to do a lot of programming and research, so a lot of my programming had been in the emphasis on doing data analysis in, well, brain stuff. But now I'm programming as a hobby and trying to build stuff. My brain doesn't keep. I wish I had a good brain. I could hold information, but sadly my brain tends to drop things very, very quickly. For instance, right now, this error here, I'm trying to remember why is this throwing an error. I might have to just go back to well, we should definitely fix this. Attribute error keyframe. Yeah. Oh. I have, I ended up having a lot of fun drawing the different faces for the avatar to give them different expressions because, sometimes, I found out that when I watch people online, especially those who are like PNG tubers, you'll see them getting all like angry and like, I'm very annoyed at this. But then their PNG is still, like this. So I thought it was kind of fun. So I decided to try and give the character a bunch of different emotions. It took forever to draw, mind you. I am not an artist by trade, so me trying to draw all of this was quite a feat. So we're having an error get thrown here at the bottom layer. So let's see, where exactly is going on? Here's our directory. Here's the, so we go in here. This is our directory path. So if we hop in here, our directory path, we'll first run this. And this will give us let's see here. This is going to be the frame importer. All right then. So this runs here. Typing is a very annoying. Yes, I did try, I did try and go the lazy route and thought, hey, maybe I could use AI to generate the images for me. That way I wouldn't have to, that way it would help save me some time. But then quickly I found out AI kind of sucks when it comes to trying to generate emotions. I don't know, maybe it's because there are not enough images of people who are angry or whatnot, but tell it to draw an anthropomorphic raccoon, and you don't get anything that makes sense. Absolutely nothing. I quickly abandoned that because, yeah, AI just would not do what I wanted. I tried to even get it to generate other, because the idea is that, my avatar is a raccoon. He's a raccoon in a hoodie who happens to be wearing a VR headset. Yeah, put that into... I guess that's never been thought of before because AI has absolutely no clue what the hell that is. Well, I wish I saved the abominations, but yeah, they're kind of the abominations. Nope. Go lay down. My dog is going to bark in a second. He's trying to get bothersome. Annoying dog. Okay. One dog is out. Hopefully the other one will go out at some point. Alright, so we are here now. We've done the imports. Let's go ahead and run that. Here we go. Oh. So there's our data dictionary. Here's all of the different positions with our different animation components. Alright, so now we're going to go down into here to find the bottom layer. So I'm calling this data dect, but technically this is only being called by one function here. So in order to make my life easier, we're just going to call this the directory dect. There we go. So now here we're trying to get this is a loop. We're going to go down as deep as we can to find our layer. Yeah, I understand what you mean. Like, it's quite surprising to see how, because the way models work is that it all goes, it's a prediction calculator. And because of that, it will always predict to the center. And you'll never get anything that will be spectacular with that. Like, you're not going to get anything novel or interesting. You're going to get average. For most people, average is good enough. But I think Casey mentioned it. If you watch the Primogen and the stand-up with the 4 developers, I think Casey mentioned it perfectly. And that is that at some point, average code will be too slow to do things, and we're going to have to get back to writing code in a efficient, thoughtful manner. Because at a certain point, we're going to have open up a browser and it'll take 5 gigs of data because it's so inefficiently programmed. And AI only does what it's been trained on. So if it's been trained on nothing but inefficient code, then you're just going to get nothing but inefficient programs. If you are a private equity firm, you don't really care. I mean, private equity firms, man, they suck out all the fun of everything. But if you're a private equity firm, you don't care. You just want to get a product out. And at a certain point, they're going to have to start caring, because I'm not going to use a program that eats away all of my RAM because you just don't know how to program. Very annoying. This is one reason why I... Oh. Okay, let me get my dog out. Out you go. No, no, no. Go out, out, out. Then lay down. Come on. Either out of the room or lay down. Come on, lay down. Silly dog. Okay. All right, all right, all right. So now here we're going to cycle through, and we'll eventually find this here. We're looking for the animation components. So animation components happens to be an enum, which also happens to be, let's see, there it is, directory dict. So this is going to be the animation. First is the animation emotion. We'll go with angry. And then here is going to be the animation components. And then this will be idle. What do you mean, no type? Oh yeah, I forgot. There's also the outfit section, which happens to be we'll pick lab coat. There we go. So this is what will eventually be found in our file. So this is where the error is occurring here. So once we find the animation, so technically we will be here at this layer. Yeah, this is the layer that we're going to be on right here. So let's go ahead and bring this over. We'll call that A, because I'm being lazy. And there we go. We have our idle animation. Then we have our set animation. There's the talk animation. Yeah, so they're all there. How much do you bet? I have an idea. I have an idea. Let's most likely what's going on is that because I've been meddling in this, something somewhere in here has gotten all borked. And now that it's all borked, yeah, right here, for instance, I've been messing this up, and now that it's all being messed up, it's not loading properly. I'm going to go ahead and we don't really need these right now. Because lab code has been untouched, I'm just going to go ahead and run with this. And if we check lab code, anger, just making sure. It looks like everything is correct. All right. As I mentioned, I didn't change anything when it came to how things were being set up, so I'm a bit curious why it might not be working properly. That being said, though, if it looks like I'm just importing in. Yeah, it was because of what I was messing with earlier. All of the borking I did with one of the other ones. So yeah, this will not work if the data structure is messed up. I'll have to fix that bug. But I digress. Here we go. We have our lab coats. We'll go ahead and pop that. So now we have, let's go ahead and get our frame. Oh. Batch callback object with results. Oh, how much do you bet it's because I changed it to a with? Pie chart. Yep, it is. It's because I changed it to a with. Oh, come on. Oh, come on. Maybe I will have to change it from job libs. So one of the things that here that because I'm trying, the idea, what I'm trying to do is I'm trying to dynamically and actively import in images as fast as possible, compile them into an image, and then push it straight into a frame buffer. Because most of the time when it comes to animating characters, like as you can see right now how my avatar works, he's actually just a bunch of movies that are constantly being run, and then I'm just playing with what is being shown at what particular time. So if you look at the data structure here, we'll go into anger. We'll go into the mouth. As you can see here, here are the 3 frames that make up the talking animation. And then if we go here to tail, here are the 12 frames that make up the tail animation. Granted, you can't really see the tail. It's a bit low. I might have to move the tail a bit. Because originally I thought it would be, you can see the tail move around here a bit, here and there, if you look at my character's feet. It's yeah, the tail, yeah, the tail does, it moves around a little bit here and there. Not very much, though. But yeah, you can see they're all individual pieces. And the reason why is because I would mix and match these. Right now, it's not set that way, but eventually, my avatar will be able to take off and put on his headset. And then by doing so, you'll actually be able to see his eyes. Hey, 7th Power. How's it going? Building an animation tool in Python. Why Python? Because I hate myself, and I want to try and make a program that's known for not being efficient, making it efficient. I really should be using C, but I'm using Python just to see if I can actually do it. But yeah, we have all of these frames that need to get loaded up. Now, the first thing that I thought about is that, can we build a modern Clippy? Well, I mean, that's technically what LLMs are nowadays. They're modern Clippies. I mean, all you really need to do is attach a picture of Clippy, because that's what Clippy originally was. Clippy was a help tool which would try and use language, they call it natural language processing, which is, so NLP. Now, let me get the thing. Oh. Let me get the thing so I can show you what I'm talking about. Oh, thanks for the follow. Oh, thanks for the... Oh, I should definitely... Oh yeah, since we have multiple streams from different areas, I should definitely... Exactly. Bag of words. So yeah, we have Clippy here. Let's go ahead and draw our friend Clippy. That looks like a very demented Clippy. Oh, okay, he's very angry at us. But yeah, the idea is that, as you mentioned, bag of words. When you ask it, like, how to add, it will break down these individual words into tokens, exactly how natural language processing works. And from there, it will then, weight them and go, oh, you're talking about adding, and you want to know kind of how, and then it will try and run it through its network to go, oh, you want to know about this thing, which is cell addition. Man, my handwriting is horrible. And with an LLM, so our good old friends, large language models, guess what they do? They use natural language processing in order to take apart words, feed it through its own particular neural network to get to the exact same thing. So, yeah, pretty much, all you need to do is take a little graphic of Clippy and just attach them to an LLM, and voila. BERT, SciPy, yep, exactly. You're 100% right. BERT I like using BERT. Only in neural networks with a little attention? Well, it depends. I ended up doing a lot of natural language. One of my previous jobs, I had to use natural language processing in order to. I would take information, process it, then run it through a neural network as a way to categorize things. The idea was, I have a sentence, I want to categorize it as in what is this sentence connected to, and add tags to it. So then I would run it through this neural network and tag it. How'd you go? Then lay down. My dog is bothering. I don't know what he wants. He keeps bothering. Go lay down. Go lay down. Money, but we can't name it, clip it. Yeah, well, that is true. That because Microsoft owns the right. Actually, do they still own the copyright for Clippy? That is always. You'd be amazed how companies just drop things. For instance, have you ever heard of a character called Blink the Cat? Or was it Blitz the Cat? It might have been Blitz the Cat. Okay, what is the name of that game? Xbox game about a cat that has a time traveling vacuum. Blinks. There it is. Blinks. Blinks the Time Sweeper. This is a product that was developed by Microsoft, I believe. Let's see here. Was it Microsoft? Microsoft Studios. Partnership with Microsoft Studios. They actually let the copyright on this character fall. So technically, Blinks is no longer under copyright law. You could totally use him if you wanted. Because usually you have to usually renew it, and they just didn't bother. All right. Let's see here. So, does Microsoft still, or I should probably type in just Clippy copyright. Yes, you're 100% right. It was because it wasn't popular. The game came out, there were 2 games that came out on the original Xbox back in the year 2000. It did not sell well. It sold really, really badly, I should say. And because of that, Microsoft never bothered to renew any copyright on it, and they just let it fall out of trade. It's finally... Oh, let's see here. Have they... Oh, actually, I did draw Clippy correctly. Interesting. This is 1997. go away. We're no experts on trademark, but surely Clippy would be legally locked up back in 96. But before... Oh, okay, you're no help. Oh, here we go. Trademarks. I wonder if this will have it. Now, usually you want to look up these types of things, like trademark law. Clippy. Here we go. Clippy filed... Wait, they filed it? When was this done? Employee, Clippy. I'm looking to see... I don't see anything... Oh, here. Microsoft Corporation. There we go. So, wow, they copyrighted Clippy back in 2022. They filed it in 2021, and then they got a status update on 2022. Technically, you could probably fight this copyright because it's a literal paperclip with eyes on it. And most likely... For those who want to have fun with trademarks and copyright, you have to really define exactly what is in there, because you have to really define what is in copyright law. So if they just say a paperclip with eyes, then a paperclip with eyes that also happens to be wearing a tie is totally valid under the copyright. Same thing with if it's a paperclip with eyes that happens to also be, I don't know, wearing a, wearing an eye patch. So, scientific and technological services. This is the original applicant. This was manually certified. Okay. Then it's free real estate. Yeah. Exactly. Because I know that a lot of companies like Microsoft and all companies, Apple, Google, Microsoft, Amazon, they will all file these copyrights to try and protect as much of their IP as possible. But when it actually gets pushed into the realm of the public, then suddenly you end up running the risk of losing it because of various things. For instance, a court might go, any object with eyes is not copyrightable because it's too generic. And as such, you have to really make it unique. You have to really make it something unique. This is one reason why Mickey Mouse, it's not just the ears and he's a black mouse with the big round ears, but also the pants and the eyes. Because if they just try to copyright any black mouse with round ears, then the copyright law would say, we're sorry, this is too generic. So it's very possible that you could easily make a Clippy, call him like Bobby or something, and Microsoft won't be able to do anything because it's too generic. It's too generic. Copyright law is very weird. Actually, I think the source code for Blinks is out there as well. So if anyone wants to mess with the source code of Blinks the cat, they can. Anyway. Let's get back to this. Let's see here. We are... Okay, so... No, that's our virtual... It's because of what we're doing in parallel. So, yeah, that means we might have to... Because I wrote here the ability to run my code in parallel. Because I didn't want... I'm trying to load multiple images at once. So what I thought was, oh, hey, if I use something like parallel in JobsLib, then what I can do is I can load all the images at the same time and thus speed things up. And it was working pretty well, but one of the problems is that parallel would not clean itself up. So if I ended up running this line of code too many times, it would run out of memory. I think I want to build one. Heard of a guy that built psychedelics for AI. Oh, that would be interesting. That would be very fun. I know that I can't remember what the name of that YouTuber is, but there's a YouTuber who his avatar is a turtle and he has an AI piloting a little girl animation. And yeah, he got quite popular where he had that's kind of effectively Clippy right there. Let's see here. I'm gonna have to change this back. Because originally what I did was this was process is equal to this. Maybe maybe I should go instead of going this route, we should go probably for the threading route, or we can go for async. But I don't know. Maybe we could do both. Maybe I could try asynchronous on this. I'm gonna put a to-do here. Doesn't either change to threads or async. There we go. But the main thing is this here. We needed our image. We need our image. There we go. And it's processed. Man, that takes forever. Man, that takes forever. How many seconds was that? How many we're trying to make this as fast as possible. So, let's see here. Our timing was... Yeah, it took about 5 seconds. Or 4 seconds to be exact. So it took 4 seconds. Yeah, 4 seconds. Or let's see, that's closer to the end of 9 and closer to the end of 30. Yeah, but we'll call it 4 seconds. 4 seconds. That is way too short of a time to be compiling this one image. I wonder if there's a... I wonder if I have to get all of this loaded into memory if I want it to run on the GPU. Either way, let's get our image out. Alright, so here's our image. Let's get back over here to our good old friend. Okay, where's our good old friend? There it is. So this happens to be our item. We've loaded the image. So let's go ahead and crop our image. Oh. Let's run that for a second. Oh. Okay, let's go ahead and run this for a second so we can get our image manipulator up. We will now proceed to crop it. That is nice and quick. Oh. So that's our new shape right there. Which is understandable because we are... That's understandable because we're using a final image. If we actually show it, I am that show image, you'll see that... Oh, let's use crop image because it's going to be smaller. Oh. Yeah, you can see here. Here's the avatar. So we're getting all... It's pretty large because we're cropping it to all of the different points. But what is the goal? API? The final goal is to write a program that will allow me to take all of my images, because if you look at the output for this, when I generate the, let's see, do I have the output still here? Yeah, here. So this is what the output currently looks like. It's all of these random different videos. And if I pick one, here we'll grab this one. You can see here, oh, seizure alert. Okay. Maybe we'll pick idle. Idle's longer. There we go. So here you go. This is what it is. This is constantly running in the background. And I was hoping that if I could, instead of just have a video constantly playing in the background, I could dynamically compile my images so that I could then start combining animations. So I could have the character talking while the tail flicks, because you'll see here in a second, tail, there, you can see it flick right at the beginning. So I could have him talking while the tail flicks. Or when I have the character kind of bouncing around, you can see his mouth constantly moving, as opposed to him keeping his mouth closed when he does that transition between the two poses. And then likewise, I could then also, instead, because right now, I don't have it right now because I figured I wasn't going to use it, but I will at some point have it where the the headset that he's wearing is off. What library am I using? I am using a variety of them. I'm planning to use OpenCV because it is basically C++. OpenCV is C++ in or the way that it works is in Python. Let's see, where are you? It should be the image manipulator contains OpenCV right here. Yeah, here you go, CV2. And then if I go down, we'll find what? Used to replace Kippy, call him Fox. Yeah. That would be kind of fun. Because if you look here at the structure, let's get over to the data frame sample, because this is how the data is currently stored. All of the individual components. So here's the body, and then here's the mouth. So as you can see, this is one reason why I'm going to compile it. Now, the first thing that I'm figured about doing is the fact that because if you look, all of the pieces, and naturally this is going to be much faster when you have fewer parts actually a part of it. The fact that I have, how many? 1, 2, 3, 4, 5, 7 layers here. Yeah, no wonder why it takes a while to process. It takes 4 seconds. Everyone wants a Jarvis. That is true. Hey, maybe once I actually get this to work in a more efficient manner, maybe I could attach it to an AI. I'll keep that in mind as I get further along. Let's see. Yeah, there's 6, but in some of them there are 7 because of the arms. It's a lot of processing. So what I'm trying to do is, one of the first things I'm thinking of is, because right now all of the files are the exact same size. It was originally done this way to simplify. It was originally done this way to simplify the process of animating, because I just have to simply overlay. But with my current messing with OpenCV quite a bit, I figured out that actually it doesn't actually take much processing power to just state where I want the positions of the images. So now what I'm going to do is I'm going to start cropping them down to a very tiny size, which should theoretically help speed up the... Yeah, you can see it's now starting to get slow because of the parallel processing is not being reduced. You can even see it right here. I'm going to have to do something about this. Anyway, But yeah, the idea is that I will shrink it down to a cropped size image, save it, and then from there, I can then just start overlaying it. And this is where I've been trying to figure out right now. Oh, be quiet, you. Come on, be quiet, you. My dog is barking. No, 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 no barking. No barking, come on. Little one's barking. Don't know why. Bark, bark, bark. Actually, I'm hoping that because the way that this is currently set up is that it only registers. Oh, stop it. The way that this currently works is it only registers IM encode compresses, not using torch to use GPU. Actually, that's one of the things that I was thinking of. Actually, can torch? Let's see here. Let me go check that out. I know that I don't know actually if my computer has a GPU. What I'm programming on is a. Let's see here. Where's the where's the information for this computer? Maybe settings? Diagnostics. Aha, no. Not diagnostics. Okay, so this computer that I'm working on actually it has an integrated graphics card. This computer was originally designed to be a server, which didn't have any real processing capabilities. It's just a small little box. And I figured it would be fun to do programming in it. Hence why I'm using it. I have no clue where to find the information here right now. And he's still bothering. Not connective. Let's see here. Aha, this way, about. There it is. Okay. Yeah, here we go. We have an iCore 3 with 3.6 hertz. It does have a graphics card. It has a 630. A Mesa 630. All right. And 128 gigs of space. OS is 64. Windows system is like X11. And yeah, it's called Minibox. An Asus hardware model. Okay, but yeah, you can see here. So we do have a graphics card, so maybe I can push it over there. Actually, I'm controlling the emotes manually right now. I'm controlling it. I have it all tied to the numpad. So, and yeah, I have it all tied to... This was a bit of a pain because a lot of programs like to use the numpad for things, so I had to go through and start moving all of those out. So I am right. You can compress encode parameter. Oh, you are right. You can. Is there a... you are right. I know that if you go to cv2.iamright... Oh my. That, yeah, I'm going to have to definitely fix that parallel processing. It is eating up my memory. This thing's going to crash. Okay, I'm going to close this out. Yeah, that is, I'm going to have to solve that problem. It's supposed to free up the memory, but it didn't do that. Looks like the chat is not showing now. Oh, I do see it on the screen. I wonder if, oh. I hope it's still showing. Odds are, let me see here. Let me go over to kick. I see, I see. Oh, you're right. You are right. You can pass a parameter function. And I was looking at that originally, hoping that I could use, yeah, here it is right here, parameter. It's an integer, which it tells us it's an integer right here. I wonder if I can dig a bit deeper here. And I am right, JPEG quality 50. Haha, I could do that. Actually, one thing that I should probably do is, there's a lot I could do for optimizations. For one, everything is currently quite large, so I could probably shrink them down a bit to a much smaller size. And I'm also doing some cropping here. I could set the JPEG quality. This is all PNGs so that I can have an alpha background. This makes it easier for when I do the overlaying. And the output could be because ultimately this is going to be fed into, because CV2 has a, let's see here. I think I'm going to, we'll go ahead and run this, but we'll have to restart it again real quickly. But I can kind of show you what I can do right now. Once we get into memory. There we go. And then from here, we can then, oh, this is frame decked items. So here's our animation frame. So let's go ahead and process this. So while that's working, let's head on down. Yeah, here it is right here. So here's my video here's my thing for running the video. And I put in chat. I see. Yeah, I saw. It's this code right here. There's that code right there. What I'm gonna do is I'm gonna put it over here for when we're doing the saving. There we go. Yes, I can see the chat. I can see the chat. Let's see a code that will, oh, come on. Type. So this is params. Okay, there we go. Oh, perfect. That's all done there. So now let's hop over here. Back to our video window. And then here we want to do the talking. Let's let this run, and then I can run the async code here. Oh. Come on, run. Oh, let's see here. Oh, and why did it mess up? I wonder why it, I wonder why it looks that way. Very strange. Either way, did it crash? That might be what happened. No, it's still running. If I hit A... Let's see here. There we go. Okay, so it's the lighting's not right. So I need to figure out why that's messed up. But as you can see here, what I can do is once I get the animation running, I can have him start talking. So you can see it right there. He's just bouncing around. I need to figure out why the alpha's broken. It wasn't... I don't know why. It's very strange given that... Oh, I bet I know what the problem is. I bet I know what the problem is. If we go to let's see here. Let's go ahead and load up IM. It's not a problem with the... I bet it's not a... I bet it's not a problem with the processing. It's a problem with how it's being displayed. Because if I recall... Let's see here. We have talk list. So talk list should be a bunch of... Yeah, here we go. So go with talk list. We'll pick the first frame. IM show dot... Or IM dot show image. Yeah, it's perfectly fine. So yeah, it totally has something to do with the how this is being displayed. So it must be the... Where are you? So here is open, append. This is run video. Let's see here. Here it is, IM show, active list. So it has to be this right here. I'm gonna divide this by 255 just to see if that will fix the current, a temporary solution to the problem. Yep, there we go. Okay, there we go. Hey, there you go. You can see him blinking. See, there he is. He blinks, and then he talks. Da 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 da. Blink. Oh. Da 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 da. Blink. So yeah, as you can see, I'm working on it. I'm working on it. When I get it all into memory, it works fine. I think the tail should be randomly. Let's see here. Is the tail moving? Yeah, I can get the tail to, I can do that. So as you can see here, I can get it to work. The problem is the major problem. Yeah, the major problem is that this is all being stored in memory. So I need to find ways to reduce the memory footprint. One potential way is to push this all onto the GPU, which is one thing I was thinking about. Process all the images, push it onto the GPU, and then just have call the GPU which layer we want out when we're... Because the idea is that eventually I will be tying the talking. So I'll be tying the talking here to when I speak. So when every time I say something, it will talk. And then that way I don't have to constantly be hitting the buttons to make him... I don't have to constantly be hitting the button to make him talk. And then the blinking and such is going to be random. So yeah, I need... This is one reason why I want to do dynamics. So that way I can combine these two together. But I have something... I'm working on it. I have something going. I will... Yeah, I will need to figure out a bit more. If I can speed things up a bit, that's what I'm hoping to do, which is why we're doing... Which is one reason why we're first doing this here, which is cropping. I think... Because originally what I wanted to do is crop the image, because if the image is small, generally smaller, then it should mean it would theoretically mean it takes up a much smaller footprint in the memory. So the idea would be that I would crop this, potentially shrink it as well, because I don't need these to be that large. But yeah, the idea would be to crop it, and then shrink it, and then, whenever I load the image up, I could then get the position information. However, OpenCV, it doesn't do anything with the metadata. It seems like OpenCV just pretends it doesn't exist. So because of that, I either use a different program, which was what I was just looking at. Where are you? There it is, this PyX of 2. I can use PyX of 2 to save the metadata to the image. I was thinking of this. Yeah, exactly. Save it as an XMP. That way I could have the information like the position of it in a frame. However, and yeah, I could have what the original image size was located and its position in the frame on where it's located. And then when I load it up, then I could, get that information and, process it. However, it reminded me that OpenCV doesn't have access. It forgets that this exists. So, part of me just wants to be lazy and do this. Let's see here. Yeah, part of me just wants to do that. Oh. I thought I already... Oh, right. I need to... Okay, let's get item... let's see. What was our... What was that frame originally? Talk list. Okay, we'll go with talk list. We'll go with the first one. Oh yeah, it needs to be image. There we go. So the idea would be I just have this. Oh, come on, position. You are a... Maybe because it's a tuple. Oh, come on. We have our list. This should be... Oh, did I... Oh, 1 second. It's not format, is it? No, it's not format. What was that? What was that function? Not split, encode, no, mount. Not join? I think maybe it was join. No, it was not join. There's a function I remember. I used to use it all the time. I'm surprised my brain dropped it. It's pretty much where you take an iterator, you run over it, and it will just concatenate it all together. Not find, not index. I thought it was format, but not strip, not lower, not index, not translate. Because we used to do it I used to do it all the time. Then you just put your iterator in there and it would run it. Okay, well... stupid brain. Alright then. Here we go. join. It was join. Okay, why did join not work? Yeah, here's our iterator. Sequence item expected a string instance, an int was found. Oh, yeah, okay. Yes, 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 yes. Okay. All right, all right, all right. Yes, 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 yes. So there we go. So, okay, it was join. I wasn't crazy. There. So the idea I'm thinking of is this. So the item name should have a PNG at the end of it. So let's see here, item path. So why don't we just go ahead and grab a random path? Again, we're just going to grab a random path. So we'll just do /home / desktop. Make sure I actually put in the T. Frame sample, and then we'll just have example.png. There we go. Then we go item.name. It should have... Oh, actually, I need to put path in here too, because that's what that is. It's a path item. So now when I go item.name, there we go. So in this case, what we're going to do is we'll have stem. We're going to do that. Dot join. In fact, we'll go ahead and put this out. We'll put this right here. We'll call this the file name. This is just going to be a path. Or actually, this is going to be a string here. And we're going to join the stem, the item dot suffix, and then this is going to be the pos string. There we go. And then here we'll put file name. There we go. And then from this way, when I generate this list, file name, it should be... Oh, I should probably put a period at the beginning of that. Yeah, I should probably put a... Maybe I should put a period or something there before that. So, there we go. Yeah, there we go. Something like that. Okay. I know that this is a bit campy, or, you know, I am cheating a little bit, but this is currently the only thing I can think of, because I can't access metadata, and I want this to be as fast as possible. And the position information is very important. Yeah, the position information is very important, and this is all under the assumption that all of the images are the exact same size. So if I do something like this, then when I load the image, as in when I grab this file path, all I have to do is some very quick processing. You know, parse the... I need to make sure that I pick... I need to make sure that I put down a character here or something that will differentiate from the other ones, because I usually use underscores for lots of things. Oh, maybe this can be... I don't know. Let's see here. Not a colon, because colons are not allowed. Maybe a... I don't know if that would work. If that would be allowed. I need to think of something. PP. The point position. I can do something like that. PP. And then if we locate... But that would... Again... I have to figure it out. I need to put some code here that will not be confusable with something else. And then when I start doing processing, string processing, I can go, okay, file name dot find. I will simply go find pp. And then from here, we'll want to go with file name. That all the way to the end. Oh, we'll definitely want to get... Let's see, PP is 4 characters, so that plus 4. Oh yeah, I could do something like that. And odds are, I know that this is currently file name, but odds are it'll be from a path, so we can easily get rid of the PNG just by calling for the stem. So it would call for the stem. Yeah, so it would call for the stem. We would then find it, and then from here I can then get the row of numbers. So in this case, we'll put this as a -4 for now, just because that's what we'll be getting. And then from that, I'll need to... I just heard some thunder. Oh no, I think we're going to have a... I think the internet's going to drop. I just heard the weather getting bad. How about this? I've been streaming for 2.5 hours. I see it's 11 o'clock on my end, so I need to start the day. I will continue programming this later tonight, and I'll give some progress reports on how things are going. But yeah, I think we're making pretty good progress. I think that this is unless I can think of a different way of storing the position information of the images, the only other option would be to put it into a... I've covered this multiple times already over the stream today. One of the options would be to put it in a config file, but that would result in me having to create a very obtuse dictionary, because ideally we're going to have, like each of these images is going to be cropped slightly differently, which means I'm going to have to, there's either two things. Either the first thing is that I crop them individually and then I store all of the position data in the image, as in what we're going to do with a string, or each of these layers, they get, each of these ones right here, they get cropped exactly the same way, and then I store that data of how to position it in the, in the dictionary. Those are, or in these configs. Those are the only two routes that I can think of doing. So yeah, I can do something like put position right here, and then copy all of these here into there, so then I know when I get the config out, I'll know exactly where all of that is located. So yeah, that could be the first thing. Set up something like this. And then just have like the arms and the eyes and the bodies all cropped exactly the same way. That would require a bit of extra processing. So I could do it this way, or I store all of it in the name of the image, and then I just pull them out. Actually, they both require a certain level of process. I'll think about it. Until then, I'm going to hop off. I need to start the day. So it's been fun. I'll continue with this and figuring things out. But until then, everyone have a good one. I'll see everyone next time. Hopefully when the weather's not so bad, because it might knock us out again. Either way, laters. Oh yeah. I set up a lab. Check it out. Before I hop off, check it out. I set up a lab. I wonder if I should start programming. I don't think I should start programming here, because the image is a bit tiny, and I think a lot of people would want to see what's going on. So, but anyway, I have a lab now. I can start doing research. What I can do is I can go over here, put on my lab coat, and we can start talking about science. Talking about the eyes, how the brain works. Maybe we can even go over how... Oh, I know. We can go over Ghost in the Shell. Talk about how Ghost in the Shell is very, like, foresight. Like, man, I really see how Ghost in the Shell is running. I really see that's how it's going to play out in real life. We can go over that later. But anyway, laters.